Okay, it is about that time too, so let's start out. Is there any questions? We had our first homework assignment assigned last Thursday, due for tonight. Are there any questions on the homework or how to use my math lab or anything like that? Any problems you want me to go back? Yes, sir.
I have no trouble getting into my math lab. I have to change some settings on my computer with my computer person because it wasn't popping up. And
Oh.
Just saying like don't have a subscription to this website.
Sure.
So I'm catching up now because I figured it out.
Okay. Well, technically the homework will stay open until 6 o'clock for you, so after class you'll have a little bit of time to finish up. But even if you don't finish by 6, the website will try to tell you that it's going to take off half your points for being late, and it will. But when I transfer the grades, the official grade book is the Blackboard grade book. So when I transfer your grades to Blackboard, I'll correct that for you.
Thanks very much.
You bet. Yeah, that's two things I did forget to mention. Is one, if you have a pop-up blocker active on your computer, you have to make sure you give it an exception for this website because it does do pop-ups for the homework. And second, sometimes your cookie settings, your security settings have to be adjusted so that it allows cookies. Any other questions or issues with the homework? Okay, well then remember that there is a quiz that it will be due at 11:59 p.m. tomorrow. That's Wednesday, so you have, what does that leave you, like, I don't know, 32 hours to do the quiz? And that one, the website will absolutely cut you off at 11:59 p.m. tomorrow night. Those quizzes, that'd be quiz 1, of course. You do get 2 attempts. Now, unlike the homework where you have that, view an example or help me solve this or ask the instructor, you will not have those on the quiz. The quiz will just be, here's the problem, do your best, and move on. The 2 attempts are when, if you get done with the quiz and it'll show you your score and it'll allow you to go back and look through your mistakes, you can try the whole quiz again. So it's all or nothing on the quiz. You can't just retry individual problems. You have to do the whole quiz. The system will automatically take your highest score, so there's absolutely, unless you're totally crunched for time, there's really no reason not to try it again, because even if you do worse the second time, it's not going to penalize you for it. I mean, the only reason not to try it again is if you get a perfect score on the first attempt.
And you'll know that.
Yeah, the system automatically takes it, but I can actually go through and see both attempts. I can go through and see each problem and everything if I need to. If there's something silly on the quiz, like a round-off error or something like that, or you can't figure out how to enter something on the quiz, just in my math lab, let me know and I will go back in and I can fix your grade for you. Some of the things you may need, not necessarily right now, but as we go through the course. Let me get into my math lab. I should have had that up before we started talking, but there are some things, I know some people have had issues entering some stuff in the past in my math lab. Come on. There we go. Helps if I use the right username for this one. So as of right now, I believe it opened at 3 o'clock. If you click on quizzes and tests, there should be, see, quiz 1 now appears at the top of that list. An hour ago, there wasn't anything up there except for the 4 tests for the class. But that quiz is there now. You can click on that and go to it. The homework, I'm just going to flip down a few here. And this applies on the homework and the quizzes as we go through. There are tools on the left side of the screen here for allowing you to enter special things. Let's say you decide that's supposed to be a fraction. You can click on this and it'll allow you to enter a fraction. Or if it's a mixed number, you can use this one to put in a mixed number. Or if it asks you to put in symbols, you can see they have the divide and the multiply symbol over here. There's more if you need them. You can get the whole little menu here if you need to put in square roots or whatever. Most of these we won't use, but they're there for you. I guess before I close this down, does anybody have any? I already asked this, but anybody have any questions since I got it open on how my MATLAB works? Okay. As we go through it, you're going to use these helps a whole lot more. Okay, anyway, enough of that. Like I said, the quiz is open. Just for the fun of it, let's take a look and see how many questions are on it. That way you don't have to look into it and get surprised. I'm ready to start. I don't want to see the tutorial. Looks like it's 10 questions. Now the system requires me to put in a time limit. I put in a 2-hour time limit just because I figured if you sat there for 2 hours working on the quiz, you'd had enough anyway. If you need more time, let me know and I will go in and readjust it. Okay, so that's good for now. Okay, so let's start on our new material then. So last week it was about the whole numbers and operations and even a little bit with integers and the negatives. So tonight we want to talk about symbols and variables a little bit and throw that into the mix. First thing I want to talk about is that thing right there. And we're going to start out by using X, but we can use any letter. But X is the one we're most used to seeing, probably the one that we're most afraid of. It's a variable, and a variable can mean several different things. That letter that's used, in any case, it is a letter that's used in place of a number of some sort of value. And it can be in a formula, where we might have, volume is length times width times height. So each of these letters in this formula is a variable. We put it in there because in this case it's a generic number. It can be any number depending on the situation. So it is sitting there holding that place, waiting for us to find the value that needs to go in it so we can finish the rest of the formula. So we might have an object somewhere that has a length, width, and height. And we'll get the numbers from that object and place them into that formula and use them to calculate that result. It can be used to represent an unknown. We might, and we'll go over this more later, we might talk about a number plus 7 or something like that, where we just use, okay, we don't know what that number is, so we're just putting that variable in there to replace it for now. It also can be used for solving in an equation. Here, that variable is not an unknown value. It has a specific value. We just have to figure out what that value is. So in these cases, these first couple of cases, that variable can take on any value depending on the situation. In this second case, it already has a value. We just have to figure out what that value is. And there are other applications of a variable. For our formulas, we can use it just to represent a generic number. For example, we might have A plus B. And all that is saying is that we're going to add two numbers together. And it can be any number. It doesn't have to be any particular value. In fact, that's one of the first things we're going to look at tonight is our properties of numbers. And because these properties can apply to any number, it doesn't matter what the numbers are, we're going to use variables to represent them. So some of the properties of numbers that we have, some of the ones that are most important. We'll start out with the one that's probably the simplest. The identity property. And the identity property is things that you can do to numbers that will not change their values. So if we are adding or subtracting, what can we do to a number that won't change its value? Well, what can I add to 9, in other words, it'll still give me 9? 0. Perfect. So the identity property is stating that any number, so I'm going to use the letter A, plus 0 is going to equal that same number. So like I said, in this case, A represents any number we can possibly imagine. Now, when we use it a second time in the same formula, it's referring back to this first one, saying it must take on that same value. Well, that's for addition or subtraction. Now, notice I didn't put up there A minus 0 equals A, because we talked a little bit about those integers last week, and we learned that subtraction really isn't its own operation. It's part of addition. For multiplication and division, of course, there is an identity property. If I have a number like 7, and I want to multiply it by something, what can I multiply 7 by that'll still give me 7? 1. So for multiplication and division, 1 is our identity. And again, we'd use A times 1 equals A. So multiply, what that's saying is any number multiplied by 1 is going to give us back that same number. What does it mean to commute? Commute means to go from one place to another, and usually back again. Commutative property deals with, again, our operations. If I'm looking at it for addition, if I have 3 plus 7, what do I get? 10. Perfect. Does it make a difference whether I do 3 plus 7 or 7 plus 3? No. Is there any set of numbers that it would make a difference? No. No matter what numbers I use here, if I'm adding together two numbers, if I switch the order, I'm going to get the same result. So the commutative property, using variables to express it, would look like this. A plus B will always equal the same as B plus A. I can switch their order. So the question comes up, does this apply for subtraction? The answer is usually a very hearty no. Because remember, we talked with our integers or negative numbers, subtraction really doesn't exist, does it? 7 minus 3 is really 7 plus a negative 3. Well, once we've changed it to that, now we could commute them. 7 plus a negative 3 will be the same as negative 3 plus 7. But it's no longer subtraction, it's addition. So the commutative property here does not apply to subtraction, but it will apply if we change it to addition. How about for multiplication? What's 5 times 9? 45. If I change the order, 9 times 5, do I still get 45? Yes, I do. Multiplication is what we call commutative. Any two numbers, A and B, no matter what they are, A times B will always equal B times A. So I can change their orders. Now, once again, division wouldn't work, would it? 45 divided by 9 would be 5. 9 divided by 45 is going to be something totally different. It's going to be 0.2. So these only apply to addition and multiplication. So along with commutative, there's something closely related to commutative property called the associative property. The associative property applies when there are 3 or more numbers being operated on. And it also only applies when there is a single operation happening all the way through the problem. So if we have 4 plus 9 plus 7. Since there's 3 or more numbers and it's the same operation, it's all addition throughout the whole problem, the associative property applies here. Now, our order of operations says we should go left to right here, doesn't it? We should do 4 plus 9 first, which is 13, and then add 7 to get 20. But what the associative property is telling us is since this is all addition, if we want to, we can do that part first. The 9 plus 7, which is 16, and 4 plus 16 will be 20. So we get the same answer even if we do them in a different order. But that's only because this is all addition in that problem. Of course, just like with our commutative, that would not work with subtraction unless we change it to addition. Multiplication ends up being the same way. If I have a problem that is 3 or more numbers again and all multiplication, in other words, all one operation. 4 times 7 times 5, of course, order of operations would tell us to work left to right. 4 times 7 is 28, and then times 5 is 140. But our associative property again says, since this is all multiplication, we are allowed to do the 7 times 5 first, which is 45. Oh, 35, not 45. Yeah. And then we can do the 4 times 35, which is 140. We'll get the same answer. Now again, just like commutative, that only applies to multiplication and addition. It does not apply to subtraction and division. Now, one of the reasons I go through that is because I want to familiarize you with the symbols. So this would be something like this. Give myself enough room here. What this is saying is if I have the 3 numbers multiplied together, I can add the first 2 and then the third, or I can add the second and third and then come back to the first. So that's the symbols. Again, A, B, and C can be any number as long as whatever this A is the same. And the same with this B and that B. Or for multiplication, A times B then times C is the same as A times the B times C done first. Now these properties of numbers are kind of important. The associative and commutative are important, but part of the purpose of going through it here is to get you used to using those symbols and seeing the symbols. Does everybody understand what these symbols mean in each of these properties so far? Makes sense? Just a missing number of some sort? Okay. From there then, let's take a look at what we use these for. One of the, well, not even one of, probably the single most difficult task in math is to take words or a situation and put it into a formula, a mathematical formula. Algebraic formula if you want to use that word. So I might have something like a number increased by 7. This is a relatively simple generic term, but it can still be difficult to translate into symbols. Key word in here is increased by. What operation is that indicating? Addition of some sort. What 2 things are added together? A number and 7. And since we don't know the number, we can either put in X or N or Y or B or whatever letter we want. And this is something I'll warn you. In my math lab, be very careful. In my math lab, it'll give you this phrase, and then down by the answer box, it'll actually tell you to use W or Z or whatever as your variable. So make sure you do that, or it will mark it wrong if you put in the wrong letter. If that does happen, by the way, let me know and I will go back and fix it for you. But it's just something to be careful of. So this would be x plus 7 is one way of translating that. And there are several other phrases that mean addition. We could have a number plus 7. That would mean x plus 7. Bless you. The sum of a number and 7 is a little bit more complex way of writing that. The sum is referring to the result of an addition problem. So to get the sum of a number and 7, you have to add them. One that's a little trickier, 7 more than a number. Now, since it's commutative, it wouldn't matter if we wrote 7 plus x. But technically, 7 more than a number is referring to 7 being added to something. So it's going to be x plus 7, just like our previous statements are. And there are a lot of different phrases out there that indicate addition. I'm not going to be able to list them all here. If we're looking at a statement like this, four less than a number. Well, obviously we have 4 and we have some unknown number, so we can call it n or y or x or whatever. But is it going to be 4 minus n or n minus 4? Can't be either way because they're not the same. Remember, with subtraction, you can't change the orders. In this case, one is right and one is wrong. 4 less than a number means the 4 is being taken away from something. So it's this one right here. A lot of people get confused because the 4 comes first in the statement. They think it should come first in the formula. But it doesn't. 4 less than something means you're taking 4 away. Think of it this way. If you have $12 and I have $4 less, how would you get to the amount that I have? 12 minus 4. So I have $4 less than you. You're going to take your amount and subtract 4 from it to get to my amount. We have a number decreased by 4. That one's a little bit simpler, just n minus 4 or x minus 4. The difference of a number and 4. Here's where it does make a difference. If you said the difference of 4 and a number, it would be 4 minus n. The difference of a number and 4 is n minus 4, just like we have up here. Here's one that's a little tricky. Now this looks at first glance just like what I wrote up here, but it's not. What's different? The word than. This is 4 less than something, which means I'm taking 4 away from it. This is 4 less a number, which means the number is being taken away. So 4 minus x or 4 minus n. So very, very subtle difference there, but worth noting. So there's a lot of small little clues that you're going to have to look for. And the only way to get good at this is to do it. I mean, you can sit there and watch me do examples all night long. It's only going to help you to a certain extent. This is one of those things you just have to repetition and learning how to see the clues and recognizing the patterns in the words is about the only way to get good at it. I might have the product of a number and 5. What's that going to be? Multiplication. X times 5. Now, most often, when we're dealing with variables, when we're multiplying, we list the number first. Instead of x times 5, we list it as 5 times x, or just 5x. 5x implies that this is 5 times whatever the x is. Kind of like 5 inches means it's 1 inch times 5. There's 5 of them. Same with 5x's. There's 5 x's, or 5 times whatever x is. Why is it that we can go from here to here? Because multiplication is commutative. If we have two numbers multiplied together, we can switch the orders, just like with addition. Subtraction, however, it made a difference between this and this, because subtraction is not commutative. You cannot switch the orders. So the product of a number and 5 is multiplication. We could have a little bit simpler one, like 5 times a number, or a number times 5. Or we might have less, like 5 sets of a number, or whatever. There are several phrases that indicate multiplication. We'd have a number split 6 ways. What's that indicating? Division. So if my number is n or x or whatever, it'll be n divided by 6. Now in algebra, we tend to write division as a fraction. Remember, a fraction is a division problem and vice versa. So in algebra, we would tend to write it like this. Instead of n divided by 6, we write it as n over 6, which means we're dividing. Other phrases that would imply dividing, we might have the quotient of, and here again the order is important, a number and 6. That's applying n divided by 6. If it was the quotient of 6 and a number, of course, it would be 6 divided by the number, or 6 divided by n or x or whatever. Or we could simply have a number divided by 6. Again, n divided by 6 or x divided by 6. The simple statements like that doesn't take too long to get fairly good at. Like I said, the less thans or the lesses or decreased bys can be a little bit difficult, but once you get used to them, they're not too bad. It's when we start combining operations in these that it can be a little tricky. How would I write this? 7 times the number increased by 3. 7x, 7n, 7y, whatever, plus 3. Perfect. 7 times the number increased by 3. Perfect. We have 7 times the sum of a number and 3. Is that any different? First instinct is to say no. I'll give you a hint. It is different. Pretty good hint. How is it different?
Solve for x plus 3 and take the answer of that times 7.
Perfect. That's exactly it. This is 7 times the sum. Up here it was 7 times a number. So 7 times the number and then increased by 3. Here it's 7 times the sum, which is implying that we already have a sum. And the sum is a result of an addition problem. So we have n plus 3. That result is being multiplied by 7. Very important, very subtle, but very important difference there. Okay, so once we can take those, the words and put them into symbols. Next, it is time to start looking at how do we work with the symbols. One of the things I want to do before we get too far into the algebraic operations is I want to take a look at exponents. We talked briefly about things like this. What does that mean? Yep. Okay, yeah. Several of you said 8 to the third power or 8 cubed, and you said 8 times 8 times 8. And those are all very true. It's pronounced 8 cubed, and it means 3/8 multiplied together. So what does x to the third mean? That means 3 x's multiplied together. X to the fifth means 5 x's multiplied together. So if we're working with these exponents, if I multiplied x to the third times x to the fifth, what's that going to mean? Well, x to the third is 3 x's multiplied together. X to the fifth, we just saw, is 5 x's multiplied together. If I multiply those together, what do I have? Got 1, 2, 3, 4, 5, 6, 7, 8 x's multiplied together. X to the 8th. How did I manage to get that? Well, this 3 meant there's going to be 3 of them. This 5 meant there's going to be 5 of them. So in the total, it's 3 plus 5, or 8 of them multiplied together. So y to the 6th times y to the 9th is going to give us y to the 15th. Good. Bless you. So with that in mind, we can start dealing with our algebraic numbers. We said once before that 4x was an algebraic number. It has a count, the 4, and a name of x. And it's going to behave just like 4 inches or 4 cows or even 4 sevenths. I know we haven't done fractions yet, but we'll get to them someday. If I go to work with 4x, if I want to add 4x plus 13x, what do I get? $17x. Good. Because whenever we add numbers, no matter what form they're in, we first combine counts. So that 4 plus 13 is 17, and we keep the same name. So x and x, we keep it as x. So what's that going to become? 15y. Very good. What's that going to become? Can't do it. Why not? Very good. Y and z are different variables. They're different names. Just like having feet and pounds, we could not combine them with addition. Same thing here. We cannot combine y's and z's with addition or with subtraction. So that is simply 7y plus 4z. But we can run into something like this. Now here, obviously, A and B are different names, but since we have 4 different items here, we can combine something. What can we combine? We can combine the A's with the other A's. We have 8A and 5A make 13A. Then we can combine the b's. We got 3b and 2b makes 5b. Now, what's wrong with the way I have my answer written right now? Or what's missing, I should say? Yeah, we're missing something to connect them together. They have to be linked somehow. In this case, it's just going to be plus. How about this one? Do I get 11 something? Why not? They don't have the same name. One is x squared and one is x. Even though it's the same variable, they are not the same. Remember, when we add, we keep the same name. So the question here is, which one do we keep? Is it x squared or x? Well, if we have to ask that question, that should tell us that we cannot add or subtract them. Unless they have exactly the same name, we cannot add or subtract them. So 7x plus 4x is simply, 7x squared plus 4x is simply 7x squared plus 4x. There's nothing more we can do with that. Here's the first example we've had where we have a minus in front of one of our algebraic terms here, one of our numbers. The big question is, what does that mean? Does that mean we're subtracting 6n, or is it a negative 6n, or what is it? Well, the answer to that question is yes. Yeah, whichever way it's easier for you to look at. The one thing, we know that subtraction goes with the number that comes after it. So even if it is subtracting 6n, it goes with the 6n. Whichever way is easiest for you to think of. That can either be thought of as subtracting 6n or plus a negative 6n. Now, I can't sit here and tell you always make it plus a negative 6 or always make it subtracting 6n, because from one situation to the next, there will be times where it's easier to think of it as subtraction, and there will be times when it's easier to think of it as a negative. So as we go through, you'll see me sometimes treating it one way and sometimes treating it the other. If it confuses you, just please let me know, and I'll go back and I'll show you why it is that I treat it as a negative or why I treat it as subtraction in that case. Or why it doesn't matter and you can do it either way and get the same answer in some cases. And sometimes it just comes down to personal preference. But anyway, for this problem, there are things I can combine. I can combine the 8n with negative 6. I can either think of it as 8n and negative 6n or 8n minus 6n. Either way, I'm going to be left with 2n. Good. And then for the c's, yeah, either think it was positive 5 subtract 9c or 5 plus a negative 9c, and either way it is a negative 4c. Notice that negative in front of the 4 serves to connect the two together. You need to think of that as 2n and negative 4c or 2n minus 4c. That negative in front of that term and the subtraction kind of are interchangeable. Tell me what to do here to combine them. 17x and 3x make 20x. And then, so this is a negative 9y and positive 5 make negative 4y. And again, that negative just becomes like a minus in front of that 4y. Not so bad? Okay. Yeah, it is kind of bad. This is good? Good. Just like any other number, our algebraic numbers can have more than one digit. In fact, I'm going to make this even more complex. I'm going to do like this. This is just like any of our whole numbers. The reason why I wrote our whole numbers out in that long form on that first night to do some of our operations, remember, if we had something like 372, that really meant 300s and 7 10s and 2 1s. Well, the same thing here for this number. Only its place values, since it's an algebraic number, are no longer 1s, 10s, 100s, 1000s, 10,000s, and so on. The place values, the first one is still the 1s. But this is now the x place. You can see it's got that place value right there. This is what place? X squared, and so on. So if I wanted to do anything with an algebraic number like this, for example, if I wanted to add 2x squared plus 5x plus 3. Now in this case, the parentheses are not telling us to do anything first, because there's nothing I can do inside those parentheses. All they're doing is separating that part of the problem from this next part. Adding those two algebraic expressions together, or algebraic numbers together. And realistically, this is just a single algebraic number. It just has several digits. That addition is going to be just like any addition I would have with whole numbers. 2x squared plus 5x plus 3. How do I write this out? Well, 3x squared plus 7x plus 19. Notice I line up the x squareds with the x squareds, and the x's with the x's, and the 1s with the 1s. I put the x in there for the x squared. They're lined up just like I did with whole numbers. And so now I'm going to add the columns just like I did with whole numbers. And just for consistency, I'll start on the right and work my way back to the left. 3 and 19 make 22. One of the nice things, or one of the things that are convenient about the algebraic numbers, are sometimes called polynomials, I don't have to carry. These are 22 1s. It doesn't matter how many of them I have, they'll never become x's. There's no way I can carry them into the x digit. So it's just a positive 22. 5x and 7x make 12x. And again, since it's positive, I'll put a plus in front of it, plus 12x. 2x squared and 3x squared? 5x squared. Very good. So adding those two together becomes 5x squared plus 12x plus 22. The process is just like whole numbers. The one little difference we've seen already is that we don't carry with the algebraic numbers. There is another little difference we're going to run into. With a whole number, or actually an integer, either the whole thing is positive or the whole thing is negative. For example, 258 is 200s and 5 10s and 8 1s. A positive 200s and a positive 5 10s and a positive 8 1s. Come on. If I have negative 349, however, that is a negative 300s and a negative 4 10s and a negative 9 1s. Every digit is negative. So in our integers and whole numbers and real numbers, either every digit of the number is positive or every digit of the number is negative. With our algebraic numbers, however, it is possible to have a positive 7x squared, a negative 5x, and a positive 9. Each digit in an algebraic number can be positive or negative on its own, which can make it a little bit tricky doing our operations. Let's say we have 5x squared minus 9x plus 2, and we're going to add to that 3x squared plus 12x minus 11. So again, just like whole numbers, we're going to line these up. Columns lined up, x's with x's, x squareds with x squareds, and ones with ones. It's just now that when we go to do our addition, we have to be careful for the negatives. This is not 2 plus 11, it's 2 plus negative 11, which is a negative 9. This is negative 9x plus 12x, which is positive 3x. And of course, 5x squared plus 3x squared is 8x squared. So we have to deal with each digit possibly being positive or negative on its own. Which can get even more confusing if we have subtraction. For example, 4x squared minus 7x plus 2 minus 2x squared plus 9x minus 13. So again, we'll write it out vertically. I'll give this one a little more room. We are subtracting here. Starting on the right and working our way back to the left. We have 2 subtract a negative 13. I'm going to write it out. 2 minus a negative 13 becomes 2 plus positive 13. It's a positive 15. Negative 7 minus 9. Well, negative 7 minus 9 becomes negative 7 plus a negative 9, which is a negative 16. So it's a negative 16x. Now, of course, 4 minus 2 is 2x squared. What do you think?
I didn't get that one.
Okay. Yep. All right. You got to realize we're subtracting down the column. So this is not 2 plus negative 13. It's 2 minus a negative 13.
Oh, yes, okay.
So whenever you have subtraction, 2 minus a negative 13, it becomes plus the opposite. So 2 plus a positive 13. Yep. I will warn you, I think I mentioned it last week, these negatives are one of, next to the translating words into symbols, the negatives are probably the second most difficult topic people deal with in this course. I want you guys to try one. Give that one a shot quick. I'll give you a couple minutes and we'll see how you do. So again, we're going to set it up vertically just like we would with whole numbers. Making sure we line up the x squareds with the x squareds and the x's with the x's. Making sure I put the right sign in front of each of them. And this is subtraction. So we have negative 4 minus 9. Negative 13. Let's pause for a second. Any questions on that? Negative 4 minus 9 becomes negative 4 plus a negative 9. So negative 13. 11 minus negative 5. Positive 16. Very good. Positive 16x. And 5x squared minus 7x squared? Negative 2x squared. Very good. Any questions? Well, at this point, it is time to take our break. So it is 4:20, so let's come back at 4:30, and we'll start the second hour.